Right, hello and welcome. This is, I think we're up to lesson 5 now, the first one of fractions. There's going to be 2 or 3 of these on fractions because it's quite a big topic. So the first thing we're going to do is look at what fractions are. So we've got 3/4. Let's have a 3/4. There's a fraction, yeah, 3/4, 3 divided by 4, 3/4. Now this number at the top is called the numerator, and this decides how many, yeah? So 3/4, we've got 3 of them, 1, 2, 3. How many? The numerator. We know that that is the divide line, yeah, because it's 3 divided by 4, and this line here is the denominator, yeah, and this decides how big the fraction is. So we've got 3 of them, and they are quarters. How big? They are quarters. So we could do something like this to say, and I've divided that circle up into 3/4, and if I'm going to represent this fraction, 3/4, I've got 1, 2, 3. So we've got 3/4. Let's do another one just to show that there are. So that one's 3/4. So if I have one of 2/3, the numerator decides how many I have. The denominator decides how big they are. So it's divided up into thirds. So you can see the size is different now. And in fact, when the denominator number gets smaller, then you have fewer fraction parts. So the fraction actually gets bigger when this gets smaller. It's like, do you want 1/10 of an amount, or do you want 1/100th of amount? You think, oh, 1/10 is actually bigger than 1/100th. Yeah, a much smaller fraction, even though the number at the bottom, the denominator, is a bigger number. So 2/3 will be represented by this. So we just draw in where we've got 1/3 there and another third there. So we've got 2/3. So that's what the fractions actually mean, how to read the fractions. So you've got the numerator, the divide line, the denominator, how big they are, how many they are, and what they represent. Now, so that's sort of parts of things. So we could then go down to, that's an I, equivalent fractions. Now obviously these numbers are all different, but they can represent exactly the same thing, the same value. So if we have here this one there, and I'll divide that up into 2 parts, so we've got 2 parts, so the denominator is 2, so they're halves, and let's have numerators, so let's have 1/2. So 1/2 would be represented like that. Now we can have an equivalent fraction to that by doing this. And if I draw in the same amount, it would look like this, so that the top and the bottom fractions are the same. And this would then be, how many parts have we got? We've got 4 of them, so they're quarters. How many of them? We've got 2. So 1/2 is equal to 2/4. Yeah, and we're going to have to somewhere along the way work out equivalent fractions. Now when you have equivalent fractions, you're going to have to do something called simplify. simplify or simplification, which means that when you get to your final answer, you've done all your calculations, you've done your working out, and you get an answer of, say, 5/10, you would have to simplify 5/10 to the smallest fraction you can. Not the smallest physical fraction, but the smallest equivalent fraction to 5/10. And you look at the top number and you look at the bottom number, numerator and denominator, and you think, can I divide both of these numbers by the same thing? Now, you can do this in steps. Now, I always suggest that, can I divide top and bottom by 2? If I can't, can I divide top and bottom by 3? And then I'll go, no, I won't go 4. Let's say I'll go 5 or maybe 10. So it doesn't matter how many times you do this, you can repeat and see whether you can get the same answer. And you will. So this one here, we've got 5 and 10. I can divide both of those by 5. So if I divide the top by 5, I get 1. If I divide the bottom by 5, I get 2. So to simplify this fraction, 5/10, into an equivalent fraction with the smallest numbers possible would be 1/2. So 5/10 is the same as 1/2. We could draw out these little boxes again, but I'm sure you can see this, yeah? So what happens if we've got 40/100? Yeah. Simplifying this fraction, they both got lovely zeros at the end, so I could divide top and bottom by 10. And you must divide the top and bottom by the same number. So if I divide 40 by 10, I get 4. If I divide 100 by 10, I get 10. Oh, now I can simplify this number once again by dividing top and bottom by 2. So that becomes 2 and that becomes 5. So 40/100 is the same as 2/5. I've simplified that number to the smallest I can possibly get it. It's an equivalent fraction, but the numbers are smaller. And this, it doesn't matter how many steps you take. For example, do this 40/10/100 again. I could say, oh, this is easy. This is the easiest one. Divide by 2. Yeah, that would be equal to 20/50. Now I think, divide by 2 again. Yeah, equals 10/25. Now I can divide by 5. That would equal 2/5. So you see, you get the same result in the end, and it doesn't matter which way you go, how many little steps you do, because it's easier on the brain. I'll always try and do this first, unless it's something really obvious, and that is simplifying a fraction. So let's take something a little bit trickier. So we do 36/144. Now, I know that these are both in the 12 times table, because 3 12s are 36 and 12 12s are 144. So I could directly divide both top and bottom by 12, which will give me 3/12, and then I can divide both of these by 3, which will give me 1/4, a quarter. But I might not have, divide by 3. I might not have spotted that straight away. So I could have gone 36/144. They're even numbers, so I can divide by 2. So I'll go 18/72. Don't know what goes in there, so I divide by 2 again, which gives me 9/36. Now, 2, I cannot divide by 2 because I've got 9. So 2's don't go into 9, although they do go into 36. So I could say, oh, let's divide that by 3. So I get 3/12. And you see, I can divide by 3 again to give me 1/4. And so I get the same answer. That way took me 2 steps. This one was 1, 2, 3, 4 steps. It takes a little longer, but you get there in the end. So it doesn't matter. You're just trying to find anything that goes into the top and the bottom at the same time. So that's simplifying. So let's have a look at some of these questions that we might get. And now, of course, it's not as number 4. It's not just straightforward simplifying them. Sometimes there's equivalence and writing and all sorts of things. So remember, you can pause this, have a go, and then see whether you get the same as me. So 13 people take their driving test on the same day. 9 of them pass. What fraction of the people didn't pass? Right, so I know that if I wrote pass, it would be 9 out of 13, yeah? But we need the ones that didn't pass. So if 9 passed, I could do 13 minus 9, which equals 4. So that means 4 people passed. So as a fraction, 4 out of 13 passed. Or didn't pass, yeah, sorry. I don't know whether I got all the passes and didn't passes muddled up there. But 9 out of 13 passed. Take away 9, 4. 4 out of 13 didn't pass. No, don't do that. Pass. Right, what number should go in the box so that something over 81 is equivalent to 5 over 9? So this is reverse. Now we're not allowed to use the calculator. So I need to, this is simplified to that, yeah? The something over 81 is simplified to 5 over 9. So we need to go back the other way and find out what we need to do to multiply 9 to get 81. And you see it's times 9. So the 81 goes on the bottom, and in the box at the top, I also need to times that by 9. So 5 9s are 45. Which number should go in the box so that something over 3 is equivalent to 28 over 12? Now this is written left to right, but basically we're simplifying this number to get that one that way. So to get from 12 to 3, we divided by 4. So we need to divide the top number by 4 as well. And 4 7s are 28. So that's 7 over 3. Right, let's come round to some more. Write these fractions in their simplest form. 7 over 42. 7. There's the clue. 42 is in the 7 times table because 6 7s are 42. So if I divide both by 6, I get 1. What am I doing? Wait a minute. That's the answer, not the division. Okay, so if I divide both by 7, so 7 divided by 7 gives me 1 at the top, 42 divided by 7 gives me 6 at the bottom. So there's a 6. 75 over 150. Now, this ends with a 5, and this ends with a 0. So I can divide both by 5. So 5's into 75. Now you could do it this way, couldn't you? 5's into 75. 5's into 7 go 1 with 2 left over. 5's into 25 go 5. So that becomes 15. And 5's into 150 are 30. Now I can divide, 15 and 30, that's double. So just divide by 15, yeah, which gives you 1 over 2. 56 over 72, they're both even, so let's divide by 2, see where we go. So I get 28 over 36. Now they're still, so I divide by 2 again, so I get 14 over 18. Divide by 2 again, 7 over 9. Can't go any further. 324 divide by 72. I'm going to do the divide by 2. It's always easier that way. I don't know how many 72s go into that. So 324 is 150, 162. It's going to take a while, this one. Over 36. I can divide by 2 again, so that gives me 81 over 18. Now, this is more complicated. Now, I know that 81 is in the 9 times table, and so is 18. So I'm going to divide by 9. Now, 9 nines are 81, and 2 nines are 18. Don't worry if the number at the top is bigger than the number at the bottom. That's for later on. Just leave it as that so far. Write these numbers as a fraction of 120 and simplify your answers. So we've got 24 over 120. So that's how you write it as a fraction of 120. Simplify the answers. Divide by 2, 12 over 60. Divide by 2, 6 over 30. Divide by 2, 3 over 15. Divide by 3 this time, 1 over 5. 75, so we go 75 over 120. Divide by 5. Now remember that 75 divided by 5 was 15. We've done that just now. 120 divided by 5. Where are we going to go? I'll go there. So 120 divided by 5. 5's into that go nothing. 5's into 12 go 2 with 2 over. And 4 5's are 20. That's 24. 15 over 24. 2's don't go into that, but 3's do. So here you need to know your tables. 3 5's are 15 and 3 8's are 24. 90 over 120. I'm going to divide by 10 now. So I ended up with 9 over 12. And now I can divide by 3. So that gives you 3 over 4. 192 over 120. Can't see what this is immediately, so I'm going to divide by 2. So half of that divided by 2 is 50 and 45, 95, 96 over 60. I divide by 2 again, 45, 48 over 30. Still keep going. 24 over 15. Now these are in the 3 times table, so that's 8. 3 8's are 24, and 3 5's are 15. 8 over 5. Right. Now we've got 2 questions here with a. Don't forget to pause. Have a go. 2 questions here that now we get into the realm of functional skills, where the questions get bigger and bigger and bigger. Right, in the month before a show, Mai's music teacher recommended she should spend 68 hours practicing. Mai actually practiced for 60 hours in the month. Write how long Mai actually practiced as a fraction of what the teacher recommended. Simplest form. So she did 60 hours out of 68. And we're going to simplify this. So let's divide by 2, because they're both even. 30 over 34. Divide by 2 again. 15 over 17. Last year, Jeremy had 2 jobs. As a waiter, he earned £90 for 26 weekends. As a climbing instructor, he earned £720 a week for 13 weeks. What fraction of his total income was being a waiter? So we need to work out how much he earned for the climbing instructor and how much he earned as a waiter. So we need to calculate this. The waiter, he earned £90 times 26 weeks. And that calculator comes out for this one. £90 times 26, which is 2340. 2340. As a climbing instructor, he earned £720 times 13 weeks. So £720 times 13 weeks is 9360. So what fraction of his total income was being a waiter? Now the total income, we need to add these 2 numbers together. So I'm going to go down there. So 0, 0, 7, 9, 10, 11, 12. Oh no, 11. So there's the total income, and we need the fraction of being a waiter. So this is the waiter, the first one. So we've got 2, 3, 4, 0 over 11700. Now, because we've got a calculator, I mean, I could divide that by 2, divide that by 2, divide that by 2, divide that by 2, and so on and so forth until I got it right down. But I'm just going to see whether the number 2340 does actually go into 100, that 11700. So I'm going to go 11700 divided by 2340. And that goes in 5 times. So it means that this number here is 5 times bigger than that. So I could simplify that to 1 over 5. See how that's come straight to it by thinking, I wonder how many times that. Otherwise, we've got 2340 divided by 1700. I'll take the zeros off to get me 234 over 1170. Then divide by 2, it's 117. Divide by, what's 1170? 585. 585. And then I'm struggling now. But if I know that 117 times 5 is 585, I know I can divide that, but I can divide both of them by 117, which gives me 1 over 5. So yes, so use your calculator to see if that top, the numerator, does go into the denominator. Otherwise, this is going to be very tricky to find a number that goes into 117 and also goes into 585. Okay, so that's the end of this lesson. There will be some self-study stuff for you to have a go at, just so you need practice. The only way you're going to do this is loads and loads of practice. So I'll see you in the next one.